Good day, grade 12s. Welcome to Technical Mathematics. And then I know that other provinces, they've already written paper 1 and 2 for Technical Mathematics, and then other provinces haven't. But for those who have already written trial examination, this is very important to prepare you for final examination, which is still coming. And then the other issue around this technical mathematics, I would like to advise the grade 12 learners to have a examination guideline before they can go and write the final examination. It's a very important document that learners should have because it explains everything that you need to know under each topic that we are doing under technical mathematics. And then let's start our lesson. Let's start our lesson for today. All right. Like I've said, that we'll be doing trigonometry, and then remember this topic is it forms part of paper 2, and then this topic it contributes 50 plus or minus 3 marks. It's a very important topic that we need to make sure that we revise it thoroughly before we can go and write our trial, and then or the final examination. And under trigonometry is now divided into 3, which is the trig ratios, identities, and equations. And then the second one is the trig functions, the graphs. And the last part, of course, 2D and 3D problems. But today's lesson is going to be mainly focusing on only on trig ratios as well as trig functions. So those are the topic that we'll be doing for today. And then when we enter to trig functions, before we can start, just want us to remember or to remind ourselves, especially for these parameters A, K, and Q, we should remember what is the effect of those parameters. Now, you can see it says, remember that the value of A, if you see the value of A, you can see that coefficient of this sine and the coefficient of this cos, it determines the shape of the graph and as well as the amplitude of the graph. All right. And then remember, what is the amplitude of the graph? It says the amplitude is the height from the center line of the graph to the maximum or minimum. All right. That is the meaning of amplitude. But then we are going to be doing that amplitude at the later stage. And then now the effect of Q. You can see that Q, having Q there. Now we need to understand the effect of that Q. It says the value of Q shifts the graph vertically up or down. All right. Once you see that there is Q in this function, you must know that the graph is either shifting vertically up or down. And of course, the value of K's affect the period of the graph. Now, let me explain on how does this K affect the graph of the period of the graph. It says we can find the period of the trigonometric graphs by dividing the original period by K. And then original period for sine. For instance, the original period for sine, we all know that is 360. And then now, if for instance, we don't have what? We don't have, or we have that value of K in this case, you can see is 2. And then what will be the period of this graph of sine 2 theta? Then we're going to say period equals to the original period of sine, which is 360, divided by 2, then it's going to give us 180 degrees. So that's how you should now, that's how we should determine the period of the trig graphs. All right. The same applies with cos. Remember cos, the original period for cos is also 360. And then every time when we have to determine the period of a cos, then you have to take this coefficient of this angle here, and then you divide the original period with that, so that you can get the period of that particular graph. But I think we'll understand it more by the time we're going to be calculating or answering questions. And then the next part is the effect of P. The effect of P on the graph. They say the value of P shifts the graph horizontally left to the right? And then remember, when it says theta plus P, the graph shifts to the left. When it says negative, the graph shifted to the right. All right. That's what you should now remember for the effect of P. All right. Now let's proceed and see what are we going to get under this. Now under trig functions, then we'll be focusing on drawing the trig functions. We have to be able to know how to plot the trig functions. And then now we will also be doing the trig ratios. And then the last part, interpreting the trigonometry graph. If the graph is already drawn for you, then you have to be able to interpret it to answer the questions. Now let's get example under trig function and see. All right. The first, it says the graph below represented a curve of function f and g defined by. The first graph is the graph of cos, which is equals to a cos bx, and then g of x is c tan x. For x is the element of from 0 to 180 degrees. Point D is 120 is to k, and point E is 45 is to -1. Lie on G. All right. You can see that we're having two graphs, and then this one you can see is a cos graph, and then of course this one and the other terminal arm there, that is for tan graph. All right. Let's see what kind of question that we might get under this. First, they ask us to calculate or to give the period of f. Now, which graph of f? Which graph is that? Is this one? Is this one? All right. Now let's go and determine the period of that graph. Now, how do we determine the graph? Remember, it says the period, the distance it takes to complete 1 full second. Right. Now, when you draw this line, this graph from here up to there, until you reach this stage, this is a half what? The half cycle of that cos graph. And then if you still continue until you reach this stage, then it's a full what? It's a full second or full wave. Now, where it stopped, then it's going to give us our period. You can see that our period in this case is what? Is it's 180 degrees. And then let's see, yes, it's 180 degrees, the period of this graph. You see, because from this point until you reach this point, it's a full cycle or full wave. And then you can see there is 180, then that is the period of cos. Next question, determine the numerical value of A, B, and C. Now, first, we have to go and look for A. You can see this is the A. And remember earlier on, I also explained the coefficient of this cos Bx, which is A. We said A does affect the graph, the shape of the graph, and also the amplitude of the graph. Now, and then how do we determine the amplitude as well? Remember, we said the amplitude is the height from the center line of the graph to the maximum or minimum. Then if we can try to look for the amplitude of this graph, then we will be determining the value of what? The value of A. Okay, let me just remove this red line. All right. And then they say the value of A. The value of A is what? The value of A equals to 1. Why 1? Because now if you visit the center line, and then of course this is the maximum, and then this is the minimum. Then we said that if you can determine, or if you can be able to see the amplitude of this graph, then already you will be determining the value of A. Now remember, the amplitude is what it says is the height of the center line. This is the center line here. This is the center line. So the height from here to the maximum is what? Is 1, meaning the amplitude of this graph of f is equals to 1. Therefore, A is also equals to 1, because we said A, it determines the amplitude of the graph. And then B, and then remember we also spoke about B. We also explained the effect of B. We said the effect of B on the graph, it gives us what? It affects the period of the graph, right? Now in this case, we don't have B, right? Remember, if we had B, if you have to look for the period of the graph, then you're going to say the original period divided by B, then it's going to give us the period of that particular graph. But in this case, we don't have what? We don't have B. But now, how do we going to be determining the value of B? Now you're going to, because this B, you can see it is on the graph of F, and the graph of X of F, I mean, is the cos graph, right? The cos graph. Now, now we have to now remember what is the original period of the cos graph. We said is 360. Is 360. Now, what is the period of this graph now? On this, what is the period of this graph of F? You can see that we agree the period is now 180. Now, for you to be able to determine the value of B, then you're going to say the original period of the cos graph divided by the period of this graph, and then it's going to give us what? 2. So that value of B is equals to 2. Now, C, we are looking for C. You can see this coefficient of tan x, which is C. Now, for you to be able to determine the value of C, now what you can do, you can take any point on the graph of tan, any point on the graph of tan for y and x, so that you can be able to calculate the value of C, right? Now, which point do we have? You can see that I cannot be able to take point D. Why? Because the value of y is unknown there, and then the only point that I think I can use is this point E, because I'm having 45 is to negative 1. That is the point I can use for x and y. Now let us substitute that point. You can see the value of y is negative 1, and the value of x is what? Is 45 degrees. Then if you just press your calculator and say tan 45, then it's going to give us 1. So C times 1 is C. Then the value of C, of course, is going to be what? It's going to be negative 1. So that is the value of C. And then the next question, write down the value of x for which the graph of f of x minus what? G of x equals to 1, right? Meaning this graph of f, it must be on top, and then this graph of g of x, it must be below. And then where it's going to give us, if you subtract the 2, it's going to give us what? 1. Then we said the first value there is 0 degrees. Yes, because now when you look at this point here, when you look, remember the value of y is 1 minus the value of another y of this graph is 0. So when you say 1 minus 0, then the answer is equal to 1. And also in this point, what is the value of y on this point? Is 0. What is the value of y on this point? Is negative 1. Now when you say 0 minus 1, then it's going to give us positive 1, meaning that is the point. So the answer for this one is x equals to, is where x equals to 0 degrees and where x equals to 45 degrees. Number 4, it says give the equation of the asymptote of G. Give the equation of asymptote of G. Remember, what is the asymptote? We said the asymptote is a line which the graph never touches or crosses, right? Now, only amplitude it does apply on tan graph, only tan graph. You can see tan graph here, the amplitude of this is going to be this 90 here, because if you draw a line there, because we know this line is not going to be touched by this graph of tan, it will never touch it, it will just approach that line. And of course, it's x equals to 90 degrees. Remember, the question is very clear to say, give the equation. So when you have to answer this question, you don't have to write 90 degrees only, because if you write 90 degrees, then you might not get that mark, because the question is very clear that we should now write that question in terms of equation. So it must be equation, so it must have equal sign. So x is where x equals to 90 degrees. The last question, determine the numerical value of k. Where is k? All right, you can see k is from this point here, and then you can see that that point, it is on the tan graph. It is on the tan graph. So meaning you are going to take these points there, then you're going to substitute to this graph of g, so that you can be able to determine the value of k. Then that is the graph. Remember, we've already determined the value of c. We said is -1. Hence, you see that there is negative there. And the second step, you just substitute the value of y is k, and then of course x is 120, and you just press your calculator there. Then it's going to give us negative square root of 3. Then you multiply, then the value of k is square root of 3. So that is the value of what? The value of k. All right, it says the given f of x equals to tan x and g of x equals to sine 2x. For x is the element of from 0 degrees to 180 degrees. Now the first question says, draw the sketch of f and g on the same set of x's and clearly indicate all the turning points and intercept with the x-axis. So in this case, we have to now plot the graph, and then here's the graph. We've done that. You can see graph of g is a sine graph, is this red one. The red one is the sine graph, and then the last graph, which is f, is for tan graph. So is this black one. This black one is a tan graph. And then it says determine the equation of asymptote. Equation of asymptote, and then of course it's going to give us x equals to 90 degrees, because asymptote is this line that the graph never touches or crosses. It's this line here. Number 3, determine the range. Determine the range of g. Which g is that? It's the sine graph. Now, what is the range? Remember, when you are referring to range, it's all possible values of y, right? Values of y. Now, you can see that from this graph, it ranges from this point until from this point here, because it does not move above this one. It does not move below this one. So the turning point is exactly at -1, and the turning point is exactly at +1. So that is the range. So it's going to be from -1 to +1. Then hence the range of the graph is y is the element of -1 is to +1. The last question that we have to answer is number 4, which says give the period of the graph. And then what is the period of f? Let's look for f. Right, the period is 180, because that is the original period. You can see that the original period for tan, we know, is 180, and then it does not have anything before this x. If we had something there, then we're going to, remember, divide that value with the original period. Because the coefficient of this x here is only 1 there, then the period is still the same, it's 180 degrees. We still have another example under trig function. The given f of x equals to 2 sine x, and g of x equals to cos into x plus 30 degrees. For x is the element of 0 degrees to 360 degrees. Now, first question says draw the graph of f and g on the same set of axes. Now, let us plot the graph. Here is our graph. You can see the f graph is this one, which is the sine graph, and the g graph is this one, which is cos graph. Number 2, write down the amplitude of f. The amplitude of f. Remember, what is the amplitude? We said the amplitude is the height from the center line of the graph to the maximum or minimum. Now, if we have to now determine the minimum of this graph, of the maximum of this graph, you can see this positive 2 up there is the maximum point, right? Is the turning point of the graph of f, and as the same applies with negative 2 is the minimum of this graph. Now, if you take a line from this center line, and the height of what? The height of the maximum is what? Equals to 2. Now, hence, the amplitude of that particular graph is equals to 2. It says determine the period of g of x minus 60. What will be the period? The period is still the period is 360. Which graph is that? The graph is this one. You can see the graph is this one. The graph is still what? It's still 360, because you can see we don't have anything here. So we still have to write the original period of cos. So the period is 360. For which values of x is g of x less than 0? For which values of x is g of x is less than 0? We said is 60 to 240. Now, when we have to answer this question here, then we'll be looking at this graph where it's less than 0. And then we all know that it's going to be less than 0 below what? Below x-axis, because it's going to be negative. Remember, anything which is less than 0, it must be negative. And then this graph of g, of course, is negative below the x-axis, which is this side. You can see this portion here is negative, 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 until this point. And then above the x-axis start to be positive now, then it start to be positive. And also on the side is positive, But remember, question says we need to determine the value of x for this graph of g of x is less than 0. So meaning where is negative? You can see it's negative from this point here, and then now we have to look for that point, and then also this point here. And then the value of x on this point is going to be 60, and the value of x on this point is 240 here. So hence we say x is greater 60 degrees and less than 240 degrees. So that's where the graph the graph is less than 0. So it's this portion here. Let me just show you. Is this part or this curve here? That's where the graph is less than 0. All right. And I think we're done. Given the graph of x equals to sine theta plus q, and then g of x equals to a cos k theta for the domain, theta is the element from 0 to 180 degrees. You can see the graph of f is the sine graph, and graph of g is the cosine graph. Now the first question says write down the amplitude of what? Of g. Which g is that? Is this graph of g. Now remember, for you to be able to determine the amplitude, you need to know what is the maximum value or what is the minimum value on this one. You can see the maximum value is this 2. You can see that is the turning point of that graph, and then and minimum value is -2 in this case. Now, for you to be able to determine the amplitude, you're going to say you have to take a height from the center line to the maximum, or sometimes you can take it to minimum. So you can see that height is 2 units there. So meaning the amplitude of that graph is what? Is equals to 2. So that is the amplitude. What is the range of f? What is the range of f? Right, let me just remove this and let us look for the range. Now the range is from this point. You can see it starts here and then it ends here. You can see that because that is the turning point. It does not move below this 1 and does not move above this 2, meaning the graph of this f is arranged between these two values, +1 and +2. So hence we say y is greater or equals to 1 and y is less than or equals to 2. That's where the graph range, right? It ranges between those two values. The next question, what is the period of G? What is the period of G? The period of this graph here. Now, for you to be able to determine the period, we have to see if the graph, where the graph is going to give us the complete full circle. Then if you take from this point, then you move until you reach the turning point there. I think there is going to be half circle or half wave. But if you still continue moving until you reach this point, then it's going to give us full circle or full wave. That's where you're going to obtain your what? Your period. And then it's very clear that the period of this graph is 180, and then that is the answer for that question. The period is 180 because that's where the graph gives us what? The complete one full circle or full wave. And number 4, it says determine the value of A, K, and Q. Where's A? Here is A. And then remember earlier on we also explained around A, the coefficient of cos. We said that A does affect the shape and also the amplitude. And then already we have determined the amplitude. And in this case, I think the amplitude was 2, then hence the answer is going to be 2. The value of A is going to be 2. Yes, it's -2, or it's -2, not 2, because you can see this is not the original graph for cos. We can see that this graph, it reflected across the line of x-axis, right? But now, if you want to get the value of this A, what you can do to get the value of A, you can do what? You can just substitute the value of, you can look for a point. For instance, you can take this point here. You can see, you can take these coordinates there, which is 90 to 2, 90 to 2. And then if, let's say, we have determined the value of K, you can see the value of K is 2. Then now you substitute the value of theta, which is 90. The value of Y is 2. Then it's going to give us the value of what? A as -2, right? Now, the value of K, they say is equals to 2. Then how did they determine the value of K? What they did, these people, is that they have looked for the original period for cos, which is 360 degrees, divided by the period of this graph that we are having right now, which is 180. Then if you divide 360 with 180, then it's going to give us what? 2. So the value of K is equals to 2. And then of course the value of Q, which is equals to 1. And then you can see the graph. Normally the graph of sine starts here at 0, but now you can see it shifted up there to +1. And then again, if you also want to calculate that value of Q, what you can do, you can take the point that is on this line or this curve of F, you can take this point here, the coordinate of this point, which is 90:2, and then if you substitute 2 where you see y, and then 90 where you see theta there, then you just press your calculator and solve the value of q, then it's going to give us +1. And the last point of question, it says write down the coordinates of one point for which f of x equals to g of x. So that point is where the two graphs intersect, and they only intersect at this point. And what are the coordinates of that point is 90:2. So where the two graphs, they are equal, is where they intersect each other. Given f of x equals to cos 2x and g of x equals to sine into x minus 45 degrees. You can see the two graphs are here. Of course, the cos graph is this one. You can see the cos graph, and then now the g graph is the sine graph, right? And then let's see what question we might get. First, we need to write down the period of of f. And f we agreed is what? Is the cos graph. And then what is the period? Then the period is going to be what? 180. We said that this value of b or k there, it affects the period of the graph. Now we take the original period of cos graph, which is 360, divide with 2, then it's going to give us 180. So that is the period. But even if you don't do that, you can see the full cycle is from this point until you pass the turning point, and then you reach this point here. That is the full cycle or full wave for cos graph. And then you can see the period there is 180 degrees. Write down the coordinates of A and C. The coordinates of A and C. Point A is this one here, and point C is this one here. Then what C? The point C, you can see at this point, graph of cos is 0, graph of sine is 0 as well. So the coordinate of that is 45 degrees is to 0, and of course the point C is 225 and is to 0. Those are the coordinates of point A and C. Which values of x are f is greater g? Which values of f of x is greater g? The graph of f is the cos graph, and then for this graph of f to be greater of g, it must be above the graph of g. For the graph of f of x to be greater of g, surely it must be above the graph of g. And then where is the graph of f above graph of g? Is from, I'm going to show you with this red, is this point here until here, and also from this point here until this point here, and then it's from this point D up to there. So that's where the graph of f is above the graph of g. So, and then if that is the case, then that's where the graph of f of x is greater g of x. Now then we need to now determine the value of x. You can see from here, and this one is from 0 degrees to 45 degrees. That's where the graph is what? Is greater g, the greater g of x. And then again from point B here to point C, that's where the graph of f is greater the graph of g. And then here is those are values 165 and 225. X is greater than and x is less than 225. And the last one is this from point D up to the last point there. And then that's where it's x is greater 285 and x is less than 260. That's where the graph of f is greater the graph of g. I think we are now done with the graph, the trig graphs. We are now into trig ratios, and then let's get example from the trig ratio. In the diagram below, t, which is -6, is t. It's a point in the Cartesian plane, OT equals to 10 units, and the angle that is formed by OT with the positive x-axis is theta there. And then for you to be able to answer this type of question or under trig ratios, then you must be able to know these ratios that we're having, that we can see on the screen, sine theta, cos theta, tan theta. Is very, very important, my dear learners, to remember the trig ratios, because only trig ratios they can help you to answer trig ratios questions. All right. For instance, if we talk about sine theta, you must know what is equals to tan theta. It's opposite over hypotenuse, which is equals to y over r. Then we got it from this this right angle triangle. You can see from this point, from the center of a circle up to this point r, that length is r, which is hypotenuse. And then of course from here to here is y, and then from O to this point there is x. All right. Now let's try to answer this question. The first, we should now determine the value of p, and then you can see the value of p in this case is the value of y. It's y. Now we need to determine the y value. Then how are we going to do that? First, we're going to use Pythagoras, because now if you just extend a line which is going to be perpendicular to x-axis there, then of course we are going to use what? Theorem of Pythagoras to calculate the unknown side. You can see from here up to there, there's -6. It's -6 there, and then of course this side here is going to be p. Then now we're going to calculate the value of y, and then we just substitute. Then -6 squared is 36, p squared, and equals to 100. And then now we transpose, and then because we calculate the value of p, then we had to get rid of this exponent 2 by square both sides, plus or minus. Then the final answer is +8. Then I believe, or you understand, that why we did not take the -8, then we took in a +8. Why? Because now you can see that this terminal arm, it is on the second quadrant, and then on the second quadrant we all know that y is positive in that quadrant. Hence we have taken what, this +8, not -8. For instance, if it was on the third quadrant, the terminal arm, or on the fourth quadrant, then we're going to have p as -8, right? Now determine cos theta. Then we know that cos theta equals to x over r. What is the value of x? Is -6. What is the value of r? Is 10. Then when you simplify it, it's going to give us -3 over 5. Then sine squared theta plus 4 tan theta. We know sine is y over r, tan is y over x. Then you just substitute the values there. You press your calculator, then the value is -4,693. So that is the value of what? Sine squared theta plus 4 tan theta. Example 2. In the diagram below, P12 is to -5 is a point on a Cartesian plane with origin O 0 to 0. The reflection angle that is formed by OP with the positive x-axis is now equals to is theta. You can see the terminal arm, it is on the fourth quadrant, and of course if you just draw a line like this, then this 12 is for x, and then this -5 is for y. So what we don't have is the value of r. Now determine the length of OP, which is the value of r. Then of course we're going to use the theorem of Pythagoras to determine that. Then you just substitute there, and then you say 12 squared is 144, 5 squared is 25. You add them together, they give us 169. Then you square both sides, then the answer is going to be 13. So the value of r is 13. Now we have to determine 5 cot theta equals to 13 cos theta. Then we know that if you reciprocal of this cot theta is what? Is cos theta over sine theta. And then the third step, we know cos theta is x over r, and then sine theta equals to y over r. And then the last one, which is cos theta, is x over r. And the fourth step, you just substitute the values there, which is 12 over -5. Because now if we simplify this one here, then we're going to be left with what? With x over y, because this r and r, they are going to cancel each other, going to give us 1. Then we'll be left with x over y, and then x is 12, and then y is -5. X is 12, and then r is 13. Then you just press your calculator there, then it's going to give us -24. All right. Given that cos beta equals to -square root of 7 over 4 for beta is the element of 0 to 180 degrees. Determine without the use of calculator the value of what? Tan beta. Now, in this question, before we can go and answer the question now, we need to have the diagram. We need to draw the diagram first. We first have to draw the diagram in order to be able to calculate the unknown side, right? Now the diagram that we are looking is going to be on the second quadrant. Now, why on the second quadrant? Because based on the restriction, it say from 0 to 0 degrees to what? To 0 degrees to 180, from to 180, meaning it's either the terminal arm is going to be on the first quadrant or on the second quadrant. Now we have to choose only one quadrant, because only one quadrant is the correct one. Now, and then we come here. Remember, when you talk about cos beta is what? It's x over r. And then remember, r is always positive. R is always positive. Now, it's very clear that this negative is for x. And then between which quadrant is x is negative, which quadrant is negative, then of course it's going to be on the second quadrant, because on the second quadrant, that's where x is negative. Then that's why the terminal arm is on the second quadrant. And then now, because now we have 4 as r, and then negative square root of 7 as x, then we don't have value of y. We first have to determine the value of y by applying the theorem of Pythagoras. Then you just substitute there, and then you transpose that 7 to the right hand side, and then you square both sides, plus or minus. The answer that we are looking for is going to be +3. We're not going to take -3, because we know that the value of y on the second quadrant is positive. All right, hence we have to use +3. And now we can be able to go and answer the question. And then tan beta equals to y over x, and then the value of y is 3, and the value of x is -square root of 7. Then we have what? Sine squared beta plus cos squared beta. Then sine is y over r, cos is x over r. Then you just substitute the values there. Then you press your calculator. Then the answer is going to be equals to 1. All right, given that square root 3 tan theta equals to -1, and restriction says theta is greater or equals to 90 and less than or equals to 270, with the aid of the diagram and without the use of calculator, determine the value of cos theta. Now, first we need to draw the terminal arm. We need to know where is the terminal arm, which quadrant. Now, first we need to rewrite this and make tan theta the subject of the formula. So this is what we did. So that is going to be tan theta equals to -1 over square root of 3, and then which is y over x, right? Then now we can now draw the terminal arm. The terminal arm, it is on the second quadrant, but why on the second quadrant? Now, based on the restriction, then we're going to be move from 90 degrees to 270, meaning is from second quadrant to the third quadrant. So only those quadrants, then we have to draw the terminal arm. Now, if we can look, if they have to choose the third quadrant, then it's not going to be correct, because on the third quadrant, y is negative and then x is negative. Then you can see from this side, we have only negative. It does not give us positive or both negative and negative. So it's negative, then the third quadrant is out, because both x and y, they are negative in that quadrant, right? And then on this one, we have only one negative. And surely is going to be what? On the second quadrant. And then on the second quadrant is only y, which is positive, and then x is negative. Then meaning this negative is for this square root of 3. Now, after we have drawn the diagram, and then we can see that we don't have this side of what? R. We don't have R, then we'll be calculating R by using theorem of Pythagoras, and then you write the correct standard equation, then you substitute, and then the value of R is going to be what? It's going to be equals to 2, because we're going to square both sides, all right? Then now we need to calculate cos theta. We know that cos theta is x over r, and then rx is negative square root of 3. Of course, r is what? R equals to 2. And then cot squared theta minus cosec squared theta. Then we need to do reciprocal. Cot squared theta equals to what? Equals to cos squared theta over sine squared theta. And then cosec squared theta is equals to 1 over sine squared theta. Now, if you add the two fractions, then you're going to give us cos squared theta minus 1 over sine squared theta. And then cos squared theta, we know cos is x over r, sine is y over r. Then you just substitute those values there, and then you just press your calculator there, and then it's going to give us negative 1 over 2. So that is the answer that we got. All right, thank you very much for being with us on this interesting lesson. My dear learners, this is the message for today's lesson that says, believe in yourself, and all that you are, know that there is something inside you that is greater than any obstacles. I think you have a nice evening. Bye.